Hello and welcome, wonderful person. Before firewalls, before the cloud, and before the threat of global cyber warfare, there was Linux. Born from a Finnish student's mind in 1991, Linux started as a humble hobby. Over the decades, it evolved into the silent engine behind nearly every server, data center, and device in our digital world. This isn't just the story of an operating system, it's the evolution of how humans and machines learn to protect, exploit, and adapt in an increasingly dangerous cyber landscape. In this video, the remarkable journey of Linux hacking will be explored. From its curious roots, through waves of digital crime and countermeasures, to a future shaped by AI, quantum computing, and autonomous security agents. The evolution of Linux hacking mirrors the development of computing technology and the rise of cybersecurity as a global concern. Understanding this transformation requires examining how Linux, developed as a free and open-source operating system by Linus Torvalds in '91, evolved from a hobbyist platform to the backbone of modern computing infrastructure and a prime target for hacking. In the early days, from 1991 to 1989, hacking was often associated with curiosity, exploration, and learning. The Linux community consisted of passionate developers and tech enthusiasts pushing the limits of the operating system. This era was marked by experimentation with system internals, network configurations, and new tool development. Exploits were basic, including buffer overflows and simple privilege escalation techniques. Early rootkits began to appear, allowing attackers to maintain access by hiding from administrators. Primitive tools like Adore and LRK rootkits set the stage for more sophisticated malware. The threat landscape focused on learning and testing limits rather than mass exploitation. As Linux gained traction in the enterprise world from 2000 to 2010, the nature of hacking began to change. This period saw the rise of malicious actors, including script kiddies, who used pre-written exploit scripts to attack systems with little understanding. Public exploits became widely available, and tools like Metasploit simplified vulnerability exploitation. Attacks on Linux servers became common, especially against poorly secured services like SSH, Apache, and FTP. Kernel-level privilege escalations were frequently used to gain root access. Malware became stealthier, with rootkits like Narc and Tuxkit designed to hide processes, files, and network activity. This period also saw significant countermeasures, including the development of the Linux Security Modules framework and the adoption of mandatory access control systems like SE Linux and AppArmor. From 2010 to 2020, Linux became central to global infrastructure, particularly in cloud computing, enterprise servers, and the Internet of Things. This attracted advanced persistent threat, APT groups, and nation-state actors. Sophisticated malware campaigns emerged, often targeting Linux environments with custom backdoors and stealthy payloads. Groups like the Equation Group, linked to the NSA, and Russian APTs, such as Turla, developed Linux-specific malware to infiltrate critical systems. Attacks became more strategic, focusing on zero-day exploits, supply chain attacks, and lateral movement within cloud environments. Modular Linux malware like Penguin Turla demonstrated the growing complexity of threats. During this period, defensive capabilities improved significantly. Kernel hardening projects such as GR Security and the Kernel Self-Protection Project aimed to make Linux more resilient. Audit frameworks, intrusion detection systems like Oscary and AuditD, and the rise of container security tools helped organizations monitor and protect their systems effectively. Linux hacking's journey reflects the ongoing battle between threat and defense in the digital age. As technology continues to evolve, so too will the tactics and strategies employed by both hackers and defenders. The story of Linux is not just about an operating system. It's about the relentless pursuit of security in a world where the stakes are higher than ever. Between 2020 and 2005, cloud-native technologies like Kubernetes and Docker surged in popularity, with Linux as the backbone of modern cloud infrastructure. This made Linux a prime target for cybercriminals. Cryptojacking attacks skyrocketed, exploiting misconfigured containers to mine cryptocurrencies like Monero. Polymorphic malware emerged, adapting its behavior to evade detection more effectively. Artificial intelligence and machine learning began influencing both defensive and offensive strategies. Malware developers experimented with AI techniques to create evasive threats and new variants. High-profile vulnerabilities, such as Log4Shell, severely impacted Linux systems, especially those running Java applications. Kubernetes clusters faced increased targeting through misconfigured APIs, exposed credentials, and insecure workloads, with attackers deploying daemon sets to spread malware across entire clusters. Looking ahead to 2025 and beyond, Linux hacking is expected to become more autonomous and AI-driven. The rise of artificial general intelligence and self-improving malware will significantly alter the threat landscape. AI-generated exploits could dynamically analyze systems, discover vulnerabilities, and deploy payloads in real time. Malware may evolve to spread autonomously across networks, learning from defensive responses and adapting to bypass them. Post-quantum cryptography will emerge as a critical concern, as quantum computing threatens to break existing encryption algorithms. Linux systems, heavily reliant on OpenSSL and similar libraries, will need to transition to quantum-resistant algorithms. Attackers may exploit flaws in quantum-unsafe systems at scale. Supply chain attacks are likely to increase, targeting the open-source software ecosystem that supports Linux. Malicious code could be injected into widely used libraries and dependencies, compromising thousands of systems simultaneously. CI/CD pipelines, container registries, and package managers like apt, DNF, pip, and npm will become high-value targets, as Linux becomes more entrenched in military, aerospace, and critical infrastructure. It will also become a battleground in cyber warfare. Firmware-level rootkits and attacks that persist beyond operating system reinstalls will present new challenges. Despite these threats, the future of Linux and cybersecurity is promising. Security technologies powered by Linux will evolve to include real-time behavior analysis, predictive threat modeling, and autonomous defense agents. AI-driven threat hunting and zero-trust architectures will become standard practices. Projects like eBPF, Extended Berkeley Packet Filter, will enable fine-grained visibility into kernel behavior and system performance, facilitating anomaly detection. Hardware attestation and secure boot chains will ensure systems remain trustworthy from power on to runtime. The future will see Linux not just as a target, but as the platform powering advanced defensive technologies, cybersecurity operations centers, threat intelligence platforms, and automated incident response systems will run on hardened Linux distributions. In fields like space exploration, robotics, autonomous vehicles, and military applications, Linux will continue to provide a secure and intelligent foundation. The battle between attackers and defenders will become increasingly automated, intelligent, and complex, with Linux at the core of both offensive and defensive strategies. This narrative is not solely about danger. It embodies innovation. Understanding the evolution of Linux hacking, from its exploratory beginnings to its AI-driven future, prepares for upcoming challenges and harnesses open-source technology to build a safer digital world. As the digital landscape evolves, Linux stands as more than an operating system. It represents a battlefield, a fortress, and a forge. The technology powering smart devices also shields critical infrastructure from nation-state attacks and runs AI that intercepts threats before they strike. By learning from the past and building for the future, the role of open-source defenders in a constantly changing digital world can be embraced. The future of Linux hacking transcends merely outsmarting attackers. It redefines possibilities in cybersecurity. It begins now with knowledge, innovation, and collective action.